Hello student, here we will start the last unit of M2, that is unit 6. It is about multiple integral. Multiple integration, here we have to learn double integration, triple integration and applications of double and triple integration. So this video lecture is dedicated to initial part of double integration. That means you will understand first what is the multiple integration and then you will learn how to solve the double integration. So students, let's start with multiple integration. So what is multiple integration and how it is different from single integration? So as you know, single integration is if we have a function of one variable, let f of x, and you want to integrate it with respect to x, then it is called single integration. Single integration can be definite integral or maybe without limits also. But what is multiple integral? So the multiple integral is a definite integration of a function of more than one variable. Like in double integration, you are having f of xy and you want to integrate it with respect to x and y both. With respect to some region, from there you will get the limits of x and y. On a similar way, triple integration, if you have a function of three variables, say x, y, z, and you want to integrate it with respect to x, y, z, all three variables along the volume V. And this volume V will give you the limits for x and y, z. So in double integration, we have one function of two variables like f of xy. That is real valued function. So here we are learning all integration related to real variable and real values. Okay, so let f of xy be a real valued function in two variables, let's x and y. And R is a region given here, which is a bounded curve in xy plane. Then the integration of f of xy with respect to x and y, it is called double integration. So here, suppose it is our closed region R for which we want to find out the integration. This R can be any closed curve, it can be given by any type of figure, and for that maybe mathematical equations are given. Now we learn some properties of double integration. So the first property on double integration is integration of k f of xy dA is equal to k outside the integral of f of xy dA, because k is a constant, so always same as the single integration, we can take k outside from the integration. The second property, if you want to find out the integration of sum or subtraction of two functions, then it is the sum and subtraction of integrals of these two functions. So integral along the R f of xy plus g of xy dA is equal to integration along the R f of xy dA plus minus integration along the R g of xy dA. Now the third property, which is very important property, is related to this figure. So till now you are able to find out the double integration along the given R thing. Okay, means this region is given as R. Okay, but now you have not given one region. You have given two region, and the union of these two region is your R, and you want to find out along R, which is the union of two region R1 and R2. Then the property is like that: f of xy dA along the region R is equal to f of xy dA along the region R1 plus f of xy dA along the region R2. So the integral along these two regions, then sum of this is equal to the total region integration. Now, important note that I'm using here dA, and in the previous slide I used dx dy and dx dy dz. So what is the difference between this? So dx dy is nothing but the area of that particular small region, and it is denoted by dA. So dA is always replaced with dx dy for Cartesian, and dA can be replaced by r dr d theta for polar. But here in this we are just concentrating on Cartesian double integration. So we will just take always dA is equal to dx dy. As you all know, geometrical meaning of single integration. So what is the geometrical meaning of single integration? It is area under that curve. So suppose this is our curve f of x, which is denoted by this yellow line, and we want to find out the integration of fx with respect to dx from 0 to a to b. Sorry. So we want to find out the value of a to b fx dx. So this blue portion is area under that curve from x is equal to a line to x is equal to b line. So always the single integration will give you the area under that curve. So similarly that we want to find out what is the geometrical meaning of the double integration. So it is nothing but the 3D volume under a surface. So how it is possible? So I want to show you this using this figure. So here suppose I am having x limit as a to b. So this is your x limit, that is a, and x limit is b, and y limit is from c to d. So here you will get in x or y plane a rectangular shape. This rectangular shape is given. Now along this rectangular shape you want to find out the integration of this z is equal to f of xy. So we will just plot z is equal to f of xy, then it is given by this surface. So this surface we want to find out the integration of this surface along this rectangular shape, which is our region is given. Okay, so what we have to do, we have to stretch this rectangular region up till this will cut by this surface. Then you will get this type of shape. It is nothing but the volume covered by this surface within this region. So that's why it is the 3D volume under a surface. So in double integration, we have to learn 5 topics. So the first topic is double integration when limits are given. Second, double integration by determining the limits, means the limits are not given, only r is given. So we have to find out limits through the region r. Then change of order of integration, then change into polar form, then application of double integration to find area. In this first video lecture, we will emphasize on first 2 topics, that is double integration when the direct limits are given, and the second when limits are not given, instead of that r is given. So using r we have to find out limits. So whenever we have to do double integration, so the first problem is what will be the order of integration. Because in double integration we have to integrate with respect to 2 variables x and y. So we have to decide for which variable we have to integrate first. Okay, so for this situation we are having 3 types of problems. So I will demonstrate one by one. So the problem 1 can be of this type. So before going to elaborate it, I just want to tell you what is internal limit and external limit. So here we are having 2 limits. One is on a left hand side and second is on a right hand side. If then left hand side limits are called external limit and right hand side limits are called internal limits. So now here we have to first check internal limits. If internal limits are in terms of x, that is f1x and f2x, then it is what for y. So we have to integrate first with respect to y. So again I repeat, if internal limits are f1x and f2x, then it is limit for y. So we have to integrate first with respect to y and then with respect to x, and then x limit will be a to b. Okay, here we have given dx by, it means the order of integration is not related to this order, that is dx dy. With this same limits, if we have given the dy dx also, then also we have to check first internal limit. Here also the internal limits are f1x and f2x. Then we have to integrate first with respect to y, and then with respect to x, so the x limit is again, it is a to b. Okay, so it is not dependent on the order of dx dy, it is dependent on the internal limit. If internal limits are in terms of x, then we have to integrate first with respect to y and then with respect to x. Okay, so similarly we are having second problem can be of this type, where the internal limits are of in terms of y, that means it is for x. So if internal limits are in terms of y, so first we have to integrate with respect to x, and then we have to integrate with respect to y. So y limit, then it is constant, it is a to b. So here dx dy is written or dy by dx written, it doesn't affect the order of integration. So order of integration will be always defined by the internal limit. Here also internal limits are in terms of y. So first we have to integrate with respect to x, and then we have to integrate with respect to y. So the y limit will be constant, that is external limit a and b. Okay, so it is same as the previous one. So we have to check from both, what we understood, that we have to check the internal limit. If internal limit is in terms of x, so first we integrate with respect to y. But if internal limits are in terms of y, so first we integrate with respect to x. Now take the third example, where both internal and external limits are constant. So it is very tedious job to find out for which variable we have to integrate first. Then always you have to choose these limit as a right to left. So in the first problem here, it is external limits are constant as a to b, and internal limits are as c to d, which are constant. So we are not able to identify for which variable we have to integrate first. So we will then second preference will be given to that order of dx and dy. So if dx dy is given, so first we have to integrate with respect to y, and y limit will be internal limit, that is c or d, and then we have to integrate with respect to dx, so x limit will be a to b. So we have to always take, if both limits are constant, so we always take the order from right to left. So on the right side we are having dy, so first we integrate with respect to y and then dx. Similarly we have the second example, a to b integral, c to d integral, f of xy dy dx. So here dy dx is written and both limits are constant. So obviously first we have to integrate with respect to x, and x limit will be your internal limit, that is c to d, and then we have to integrate with respect to y, and y limits are external limit, that is a to b. So that order only follows when both limits are constant. But if both limits are not constant, internal limits are in terms of variable, so we have to find out from first or second point for which variable we have to integrate first. Okay, now here one important note, that external limit will be always constant, because the last answer should be a constant, so external limit is always in all cases will be constant. So now we are starting first part of double integration, when the limits are given. So when the limits are given, then how we can solve the double integration. So we are having four types of problem in this. So one by one we will see how to evaluate the double integration if limits are given. So first, double integration over the region R can be evaluated by two successive integration. As we already discussed that if internal limits are given in terms of x, so we have to integrate it with respect to y and then with respect to x. So what we have done, we took the internal limit f of xy dy in bracket. So we will integrate only it as a single integration by keeping x as a constant. and then put the limit of y for f1x and f2x. So we will get this whole as a function of x, and then we will integrate it with respect to x and put the limit of x as a to b. Okay, what is the geometrical meaning of this integration? Your y limits are f1x. So this is your first graph, y is equal to f1x, then f2x. So it's your y upper limit is f2x, then x is lower limit is x is equal to a, and the upper limit of x is equal to b. So this shaded area will denote the region where we are integrating our function f of xy. So to evaluate the double integration, we first integrate with respect to y, considering x as a constant, put the limits of y as f1x and f2x. Then this whole as will convert into a function of x, and then integrate this function of x with respect to x and put the limits a to b. Okay. Now the opposite, if we have given this integration, that is c to d, f1y, f2y, f of xy, dx, dy. So the internal limits are here are in terms of y. So first we will integrate it with respect to x. So how we will write out external limit as it is, internal limit f1y to f2y, f of xy, y limits are in terms of y, so we have to keep with this dx and bracket close. This thing we have to write down in bracket, and outside of that dy. That means first we will integrate our function with respect to x and put the limit of x as f1y to f2y. Then this bracket is totally the function of y. Then we will integrate this function of y with respect to y and put the limit of y as c to d. Okay, now if we again see this as a geometrical form, so the x limits are f1y to f2y. So lower limit is f1y, so we will draw on xy plane. So this is your first x is equal to f1y, second x is equal to f2y. So lower limit and upper limit. Now the y limit is lower limit is c and y upper limit is d. So this is bounded region is denoted by this integration. So you are doing your integration of the function f of xy within this shaded area with respect to this. So what we are doing here to evaluate this integral, first we will integrate with respect to x by keeping y as constant and put the limit of x as f1y to f2y. Then we will integrate whatever result we will get, we will integrate that with respect to y and put the limit of y from c to d. So the third type, when internal and external both limits are constants. So if your integral is given as integral a to b, integral c to d, f of xy, dx, dy. So I already told you, if both limits are given as constant, so your order should be from right to left. That means we have to integrate first with respect to y and then with respect to x. So how we will rewrite it, that a to b external limit as it is, then in bracket internal limit c to d, f of xy, dy, bracket close, dx. That means internal, first we have to integrate f of xy with respect to y by keeping x as a constant and put the limits as c to d. Then integrate that with respect to x and put the limit a to b. What is the geometrical representation for this graph, this limits? So I will tell you on the graph. So it is x and y axis, and on x and y axis y limits are given as c to d. So here we will put the limits for y, that is c to d, and x limit as a to b. Then it is a rectangular shaded area. So here in this integral, what we are doing, we are integrating our f of xy over this shaded area. Okay, now maybe in place of dx dy you have given dy dx. That means you have to first integrate with respect to x and then with respect to y. While integrating with respect to x, you have to keep y as constant. Okay, so that means if your x and y both limits are constant, then double integration order should be always specified, and if it is not specified, then it is always from right to left. Now the fourth category, when the limits are constant but your function is separable function. What is the meaning of separable function? Any function f of xy is a separable function if you can write down in a factored form, in which first factor is a function of x only and the second function is the function of y only. So if you can you are able to write down your function f of xy as a multiplication of two function, in which first function is a function of x and second function is a function of y, then it is called separable function. So if your limits are, both limits are constant and your function is separable function, then how you can solve it? So I'll just give you the example. Suppose here given as y limit is c to d and x is limit is a to b. So here it is specified that internal limits are limits for y and external limits are limits for x. So here in this way, in any question it can be specified. If it is not specified, then always we have to go from right to left. Okay, here if your function f of x y can be written as ux into vy, then you can separately take ux with respect to dx integral and the x limit as a to b, and you can simultaneously integrate vy with respect to y by taking the limits of y as c to d. So if your function is separable and limits are constant, then it is a multiplication of two single integrations. So let's start with examples on the first type of problems on double integration when the limits are given. Okay, so I'm taking the first example here. So evaluate 0 to 1 integration and integration x square to x, xy into x plus y whole dx dy. So we have given our function as xy into x plus y, and we have to integrate it with respect to x and y, and limits are given as 0 to 1 and x square to x. So first it is very necessary that identify the external and internal limit. So here external limits are 0 to 1, which are constant, obviously it should be constant, and internal limits are x square to x. So this is your internal limit which are in terms of x. So it is in terms of x, so we have to integrate first with respect to y. Okay, so how we will write down it? So we will write down it as external limit 0 to 1, internal limit x square to x, whole function, that is x square y plus xy square. We have multiplied xy in the bracket, and x limits are given, so it is for y. So first we will integrate with respect to y. Okay, so it is very important. First we will integrate, so it is within the bracket, and then outside of bracket we will write down the dx. Okay, here it is very important, you are integrating with respect to y, that means you have to keep x as constant. Okay, so if you will keep x as constant and integrate with respect to y, then here what it will be, x square as it is, y integration will be y square by 2 plus x as it is, y square integration will be y cube by 3, and its limits are x square to x. Okay, and then whole integral dx, and dx limits are 0 to 1. Okay, so now just put the limit of y, upper limit as x and lower limit as x square. So you will get this as a function of, this whole as a function of x. Okay, so just integrate with respect to x, you will get this expression, and put the limits of x as 0 to 1, so you will get this number, and if you evaluate it, you are getting 3 by 56. That will be your answer. Next example here, evaluate integral 0 to 1, integral 0 to y, xy e raised to minus x square dx dy. So again, just identify the internal and external limits. So here internal limits are 0 to y and external limits are 0 to 1. So external limits are obviously constant, but here internal limits are in terms of y. Okay, so if it is in terms of y, so we have to integrate first with respect to x. Okay, so we have to integrate it with respect to x, then with respect to y. Okay, so what will be your solution? So for solution we have to write down the internal limits and dx in the bracket, so it will be like this. Okay, what we have done, we have took minus y by 2 outside of the internal integration, because internal integration we are integrating with respect to x. So with respect to x, y is constant, and if it is y is in multiplication, so we can take outside it because it is a treated as constant. Okay, so we will integrate it, but while integration, again you have to remember, you have to keep y as constant. Okay, because you are integrating with respect to x. Okay, so just integrate it. How you can integrate? Here you can put minus x square is t, then minus 2x dx will be dt. So minus 2x dx is dt. If you put minus x square is equal to t, so it will be e raised to minus t dt. Its integration will be e raised to minus t. Okay, so here e raised to minus x square, and its limit is given as 0 to y. So you have to put 0 to y limit, so you will get this thing. Now you have to integrate, so again put minus y square is equal to t, and you will get this as an integration. Now put the limit as 0 to 1, you will get this expression, and the last answer is 1 upon 4. So next example, when the limits are constant and function is separable. So here limits are 0 to 1, 0 to 1, dy by dy dx whole upon under root of 1 minus x square into 1 minus y square. So you can easily see that we can rewrite this function as 1 upon under root of 1 minus x square into 1 upon under root of 1 minus y square. So the function is separable and the limits are constant. Okay. Now the order is given as dy dx, as in this particular question both limits are same, so anyone can be for x and other can be for y. But if limit will be different, then the internal limits will be for x and external limit will be for y. Okay, so if we rewrite it, so as functions are separable, so we can rewrite it as dx upon under root of 1 minus x square integration with respect to x with this with limits 0 to 1, and the second as 1 upon under root of 1 minus y square integration with respect to y, and the limit says 0 to 1. Okay, now we will integrate it, so it will be sine inverse x and limit is 0 to 1, and the second one is sine inverse y and the limit is 0 to 1. So both will be sine inverse 1 minus sine inverse 0, sine inverse 1 minus sine inverse 0. So the pi by, if 2 pi by 2, so the answer is pi square by 4. Now if we have completed the first part when the limits are given, but the second part when the limits are not given, instead of limit we have given the region R. So using this region R, we have to find out the limits for the double integration. Okay, so in that how it is given, so it will be given as double integration R f of xy dx dy, and second it can be in a form of double integration along R f of xy dy dx. So first you should know how we will read it. So it is the notation for double integration. So double integration, and here in the suffix format it is given as R, or it can be written the below to that. So it can be read as along R. So double integration along R f of xy dx dy. We will again read it as double integration along R f of xy dy dx. So if it is given, so I told you that if limits are not as specified, internal limits is not given, so always we will go right to left. But here it is our choice whether we want to integrate it with respect to x first or y first. So it is not at all depending on the order whatever given. It is depend on us for which variable we want to integrate first and for which second. Okay, but remember this thing, that if we want to integrate with respect to first variable, then the first variable limit will be in terms of other variable, and then second variable limit will be always constant. Okay, so here if we want to integrate with respect to y first, then find the limit of y in terms of x and limit of x as constant. Okay, so now for that I'll just show you one figure. So how we will find out the limit in that thing. So if you want to find out the limit of y in terms of x, so in your region you have to draw one strip, that is a vertical strip. Okay, so if you will draw the vertical strip, then the entering, that is the lower arm of this strip, will give you the lower limit of y, and then upper arm of this strip will give you the upper limit of y. Then the left side, how much your strip can move, will give you the lower limit of x, and the right arm, up to which point it can move, it will give you the upper limit of x. Okay, so first, whenever region is given, you have to draw region in your x or y plane, and in that, if you want to integrate first with respect to y, then you have to draw one vertical strip, and by this vertical strip you can find out the limits first for y and then for x. Okay, so similarly, if you want to integrate first with respect to x, so you have to draw one horizontal strip. Okay, so the numbers will be left, right, lower, upper. So left and right arm will give you the lower and upper limit of x, and the lower and upper arm of the strip will give you the lower and upper limit of the y. Okay, so here, one note, special note here. So please remember this thing, that limit of last variable is always constant. I already told you that limit of last variable is always constant. So keep this in your mind, because many students do the same mistake, that y limits in terms of x limit in terms of y, but it should not be the case. First, you want to integrate with respect to y, then y limit should be in terms of x, and x limit should be constant. On opposite side, if you want to integrate firstly with respect to x, so x limit should be in terms of y, and then y limit should be constant. Okay, now the second thing, key for second variable, if you want to find out limit, then you have to move. So always remember the word moving if you want to find out the limit for the second variable. So let's first example on when the limits are not given. Instead of limits, we have given region R. So the first example is evaluate double integration along R f of x y dx dy over the region R given by x equal to 0, y equal to 0, and x plus y is equal to a. Okay, so whenever you have given any problem here, when the region is given instead of limits, so first you have to decide for which variable you want to integrate first. Okay, so here for this same problem, you can integrate it with respect to x or with respect to y. So here we can solve it through two methods. So I will elaborate here by both methods here. Okay, so first method, in which we will integrate it with respect to y first and then with respect to x. Okay, so whenever you have any questions, so first decide for which variable you want to integrate it. Okay, first. Okay, so after deciding it, you have to here draw this region on xy plane. Okay, so I took here xy plane, I just draw x equal to 0. X equal to 0 is nothing but y equal to y axis, and y equal to 0 is x axis. Now I will draw the third line, that is x plus y is equal to a. Okay, so I am giving you here a shortcut method how to draw a straight line directly if it is not any axis. Okay, so I am here just elaborating how I have drawn here x plus y equal to a. So x plus y is equal to a. If you want to draw this line on x or y plane, so what you have to do, you have to put y equal to 0 one time and get the x value. So you will get a equal a 0 point. So here it is a 0 point. A 0 is always will be on x axis. So just mark it here. Okay, next time you just put x equal to 0, then you will get y equal to a. Then it is 0 a point. It will be always on a y axis. So just mark this. And from just a scale, join these 2 points, then you will get your straight line which denotes x plus y is equal to a. Okay, then here it is very necessary whenever you are getting any you are drawing all the lines, then they are intersecting to each other, so you have to always find the intersection points. Like here 0, O point is 0 0, and A point is A 0, and B point is 0A. Okay, so here always you have to write it. So now we have to identify which is our area, which is bounded by all these three lines. So it is a triangular shaded part, which is a bounded area by these x equal to 0, y equal to 0, and x plus y is equal to a line. Okay, so we have this thing. Now we want to integrate it first with respect to y. So how we will write down it as integral in bracket integral f of xy dy, and then whole integral dx. So first we want to find out the limits of y limit. So I already told you, if you want to integrate first with respect to y, then you have to draw one vertical strip. So let this LK is your vertical strip, which is anywhere you can draw, but within the region R. You cannot draw here outside of this region. You can't draw. You have to draw your strip always within the region, but you can draw anywhere within the region. Okay, now what we will do, we will determine the limit of y first. So to find out the limit for y first, what you have to do, you have to just uh, move your strip from vertically. Okay, so you have to identify from where it is entering and from where it is leaving. Okay, so it is entering into the region where y equal to 0, and it is leaving the region where y is equal to a minus x. So the lower limit of y will be your y equal to 0, and the upper limit of y will be y is equal to a minus x. Okay, now we have to find out the limit for x. So to find the limit of x, we have to move the strip horizontally. Okay, so if we move the limit horizontally, so we have to find out the value of y exactly, where left side of this strip and right side of this strip. Okay, so we can see that if we move this strip horizontally, then it can move within the region at max from 0 to a. So x lower limit will be 0 and the upper limit of x will be a. Okay, so here we have to put the y limit at 0 to a minus x and x limit as a 0 to a. So our integral with the complete limit is as I equal to 0 to a. 0 to a will be the limit of x, and 0 to a minus x, f of x minus f of xy dy and whole dx. So y limit is 0 to a minus x and x limit will be 0 to a. Okay, now we will do this same problem with the method 2. Okay, so same method with method 2. That means you want to integrate first with respect to x. Okay, so we have to draw again the region. So region will be same. I will not again going in detail for the region. So this triangle OABO is our region of integration. Now I want to integrate it first with respect to x. So I took here inside of bracket dx and outside of bracket dy. Okay, so I want to integrate first with respect to x. So we will draw horizontal strip instead of vertical. We will draw horizontal strip here. Okay, that is LK. Okay, now we move it horizontally. So we will see the strip will enter to the region where x equal to 0 and exit when x is equal to a minus y. So your in lower limit of x is x equal to 0 and the upper limit of x is equal to a minus y. Now you move this strip vertically, then it can be it is for x limit. Now if you want to find out the limit for x, so you have to move it vertically. So you can see it is within the limit, it can move from y equal to 0 to y is equal to a. So y equal to 0 is your lower limit and y is equal to a is your upper limit. Okay, now we will put this limit here in step 2. So what we will get as a total integration with complete limits. So x limit we are getting 0 to a minus y, and y limits we are getting as 0 to a. So this whole are the with complete limits integration. So let's take another example. Evaluate double integration along r xy whole x plus y dx dy, where r is the region bounded by y is equal to x squared and y is equal to x. So first you have to decide whether you want to integrate it with respect to y or with respect to x. So I am solving it by taking first integration with respect to y. Okay, so just you have to keep this thing in your mind for which variable you want to integrate first. Okay, so now next step, you just draw these curves on xy plane. Okay, so we have to draw y is equal to x square parabola and y is equal to x line on xy plane. So this is y is equal to x square parabola. It is symmetric about y axis because powers of x are even. Okay, now the second is y is equal to x line is this. Now it is intersecting at 2 points, that O and A. So whenever they are intersecting, you have to find out the values of that coordinates of that intersecting point. So O is origin, you are very well known about this, but how we will get A as 1 1. So it is just intersection of y is equal to x square and y is equal to x. So you can equate it. So you will get the x squared is equal to x. So you will get two values of x as 0 and 1. X is 1, then y is also 1, then the point will be 1 1 and 0 0. Okay, so whenever you will get intersection of any two or more than two curves, you have to find out the values of that intersection point or coordinates. Okay, so now we have to identify here what is the bounded area between these two curves. So this shaded area is your region of integration. Okay, and we have decided already that we have to integrate with respect to y first. So what we will do in this shaded area, we will draw a vertical strip. Okay, so vertical rectangular strip we will draw here. Okay, now if we have drawn here rectangular vertical strip, so we will see the lower of and upper arm of this strip. Lower, that means it is entering to the region, and the upper, that means exiting or leaving the region. So see, it is entering to the region through the curve y is equal to x square. See, if you draw this strip left or right also, I have drawn here, but you can draw anywhere throughout the region. Okay, so if you draw here any point here, then the value will not be 0. Okay, throughout the region you have to check when we this strip will enter to the region, then it will enter to the region by one curve. So it is entering to the region by y is equal to x square and leaving the region by y is equal to x. Okay, so the lower limit of y is x square and the upper limit of y is x, because it is leaving from y is equal to x. Okay, now we want to find out the limit of x, so we will move this strip. Okay, so horizontally, then see, so it can move within the region from x equal to 0 to x is equal to 1. Then the limits of x are 0 to 1. Okay, now we will put this limit of y, that is the lower limit, that is the upper limit, and x limit lower is 0 and upper is 1. Okay, now we will put, then we will get the integration is like 0 to 1, x square to x, xy, x plus y, dx, dy. Okay, now we want to solve it. Then how we will solve it? We have to integrate y, and with y you just take the limits of x and then dx and x limits. Okay, uh, while integrating with respect to y, you have to keep x as a constant. So we have put x as a constant, we have integrated with respect to y, put the limits of y, that is x square to x, you will get the whole expression in terms of x. Now integrate it with respect to x, you will get this expression. Put the limit of x as 0 to 1, you will get these numbers, and the last result will be 3 by 56. Okay, now take the next example. X square minus y square. Function is x square minus y square. You want to integrate with respect to x and y along the region R, where region R is over the triangle with vertices 0, 1, 1, 1, 1, 2. Okay, so I'll just draw these 3 points on the uh, x or y plane. So here this is 0, 1, it is 1, 1 and 1, 2. I'll just join these 3 points, we will get a triangular shape. Okay, so this triangle is your region of integration, so I shaded it. So this shaded area is our region of integration. Okay, now we want to suppose find out the integration. First we want to integrate it with respect to x, so we will draw one horizontal rectangular strip. Okay, so this is your horizontal rectangular strip, so you have to check when it is entering to the region and when it is leaving to the region. Okay, so when it is entering to the region, it is through the AC line. Okay, it is AC line, and leaving the region through the BC line. Okay, so obviously for x, left side is your lower limit and right side is your upper limit. So left side is dependent on AC curve and right side is dependent on BC curve. Okay, but I don't know the equations of these lines. Okay, then how to find out the equation of these lines? So I just want to find out the equation of AC line. Okay, so how we will find out the equation of AC line? AC is the line which join the point 0, 1 and 1, 2. Then the equation of AC line will be x minus 0 upon 1 minus 0, y minus 1 upon 2 minus 1. That means the equation of this is x is equal to y minus 1. That is what where your strip is entering. Okay, so the lower limit of x is y minus 1. Okay, now we will find out the limit that line equation for BC. So you can see for BC x is constant, that is 1. So this is nothing but x equal to 1. So the upper limit of x is equal to 1 and the lower limit of x is y minus 1. Okay, now we will move this vertically to find out the y limit. Just concentrate, create and just check where what is the lower limit of y and upper limit of y. Lower limit of y, from where your strip is starting move, start move करना through within the region, and the upper limit of y when the move will stop. Okay, so here you just check, it is y equal to 1 and up to C point. At C point your y is 2, so your y limits will be y is equal to 1 and y is equal to 2 will be your upper limit. Okay, so now this whole integral can be written in terms of here 1 to 2, that is the limit of y, and internal limit, that is y minus 1 to 1, that is the limit for x. So in bracket we have written dx, and x limits are y minus 1 to 1, and outside it is dy, and y limit is 1 to 2. Okay, now if we solve it, then with respect to x, by keeping y as constant, so we will get this expression. Now put the limit of x as y minus 1 to 1, then you will get like this expression, and then just integrate it with respect to y, and before integrating just simplify that, you will get this particular expression. Now integrate it with respect to y and keep the limit of y as 1 to 2, then the answer is minus 8 by 12, that is minus 2 by 3. Next example, in double integration along our x cube y dx dy over the positive quadrant of ellipse, that is x square by a square plus y square by b square equal to 1. Okay, so now first draw your ellipse on xy plane. Okay, so I'm taking only in the first quadrant because it is asked to evaluate the integral over the positive quadrant. You can draw the whole quadrant, but shaded, you can shade only the first positive quadrant of the ellipse. Okay, so I just shaded it. So this is our region of integration. So I'm getting here 3 point, that is 0 a b. Okay, so first find out the coordinates of 0 a b. Okay, so 0 a b, 0 is your 0 point, a is your that is a 0 point, and b is your 0 b point. Okay, so now I want to integrate first with respect to y. So I have drawn here vertical strip. Okay, so after drawing this vertical strip, you can easily check the entering of the strip through the curve y is equal to 0. Okay, now leaving this strip from the shaded area where the curve value is y is equal to b upon a under root of a square minus x square. How we got this? It is leaving the region through the ellipse equation. So we will just find out the y value from the ellipse equation. So we will get that, but we will get y two values, that is plus and minus, and here it is obviously plus because we are considering the positive quadrant of the ellipse. Okay, so here the lower limit of y is y equal to 0, and the upper limit of y is b by a into under root of a square minus x square. Now we will move this strip horizontally. So you can see the left hand side, it can go up to x equal to 0, and right hand side it can go up to a point. And for a point, your x value is a. So the x limits will be 0 to a. Okay. Now if we put these limits here, so our integration will be like this: 0 to a, in bracket 0 to b by a under root of a square minus x square, integral of x cube y dy and whole dx. Okay, now just integrate it with respect to y first, and by keeping x as constant. So it is x cube y square by 2. Just put the limit of y, so you will get this expression. Now just b square by a square you can take outside as it is constant. So your simplified expression is like this. Now integrate it with respect to x, so you will get this. Now put the limit of x as 0 to a, so you will get this. Just simplify, then you will get this is your answer, that is a raised to 4 b square whole divided by 24. So next example is evaluate double integration along R 7x square plus 14xy whole dx dy, where R is the region bounded by x equal to 2y square and x is equal to 8. So here again I am solving this same question using two methods, that is first with respect to x, and in the second method first with respect to y. So I will just here give you the limits, how to find out the limit, and after that I think now you are well known how to solve it. Okay, so I will give here only the limits for this particular questions. Okay, so first I am taking here when we want to solve it with respect to x first. Okay, so for this first you have to find out your region of integration. To find out the region of integration, you have to draw x is equal to 2y square parabola and x is equal to 8 line on the xy plane. So here it is xy plane, it is x is equal to 2y square graph and x is equal to 8. So bounded area is denoted by the shaded area. Here we are getting 3 point, that is O, A, B. So O point is 0, 0, A point is 8, 0, sorry 8, 2, and B point is 8 minus 2. How we got A and B? So for A and B, the line x is equal to 8, we will put x equal to 8 in x is equal to 2y square, and we will solve, then we will get y is equal to 2 and minus 2. So A point is 2 and B point is minus 2. Okay, now we want to integrate it first with respect to x, so we will use or draw one horizontal strip, rectangular strip. Now we have to check the left hand side from where it is entering to the region, and right hand side where it is leaving the region. So here lower limit of x will be x is equal to 2y square because it is entering to the region through the parabola, and for parabola the equation is x square is equal to 2y square. Now we will check the upper limit of x, then we will check right side from where it is leaving the region. So it is leaving the region where your x is equal to 8 line is there. So the upper limit of x is equal to 8. Okay. So it is clear about the x limits. Now we will move this vertical strip horizontally, and we will take see at max from where to where it can move. Okay, so it can move lower side, from lower side it can move from -2 to +2. Okay, so it can move -2 to +2. So it is your limit of y, that is -2 to +2. So in your integration limit will be 2y square to 8, 7x square plus 14xy dx. So x limits are 2y square to 8, and then outer side it is dy, and y limit is -2 to +2. Okay, now if the same question we want to do in a other way, that means we want to integrate this same question with respect to y first, then what will happen? Okay, so if we want to find out the limit of y first, so the region will be same. We will draw the x on x or y plane, then the region of integration we will get same. But instead of here horizontal strip, we will draw here vertical strip. Okay, so we have to check the lower side of this strip from where it is entering to the region, and the upper side of the strip where it is leaving the region. So the lower limit of y is minus under root of x by 2. Why it is so? Because it is entering to the region through the parabola, but negative side of the parabola. So from the parabolic equation we will find out the value of y. So y value is plus minus under root of x by 2. So obviously the negative part of the parabola is y is equal to minus under root of x minus 2, and the upper side of the parabola is y is equal to plus under root of x by 2. So I will just check from where it is leaving the uh, region. So it is leaving the region from the positive side of the parabola, that is y is equal to under root of x plus 2. So this is your upper limit of the y, and the lower limit is negative side of the parabola. Okay, now to find out the limits for x, we will move this strip horizontally. Okay, so if we move this strip horizontally, so it is start from 0 and end up to AB line. Okay, so that's why your lower limit of x will be 0, and for AB line equation is x is equal to 8. So the upper limit of x is x is equal to 8. Okay, now we will put it in the integration. So integration with this. Okay, now the last example I'm taking here. So again this example I'm taking with both method, first with respect to x, and first then with respect to y, and second method will elaborate first with respect to y then x. Okay, so the region is given as x minus y square, that is parabola again, and x is equal to y minus 6, it is your straight line. Okay, so how we will draw it on x or y plane? So it is directly came. So the y is equal to x is equal to minus y square is the parabola which is symmetric about x axis but negative side mein jayega, and the second is x is equal to y minus 6. So I told you how to draw this line. So first time you have to put y equal to 0. Y equal to 0, that means x is equal to minus 6. So this is your minus 6 0 point, and next x equal to 0 put kariye, so y is equal to 6. So it is your 0 6 point. Now just join it and stretch it up till it will cut to the next curve. So it is your x is equal to y minus 6. Now bounded area is denoted by this shaded area. Okay, now I want to find out the limit for x first. So we have drawn here a horizontal strip. Okay, so horizontal strip may where from which curve it is entering to the region, and from which curve it is leaving the curve will be the lower and upper limit of the x. So the lower limit of x is equal to y minus 6, because from this line AB it is entering to the curve. Okay, and the upper limit is x is equal to minus y square, because from the parabola it is leaving the curve. Okay, now move this strip vertically, so it can start from B point and it can end up to A point. At B point y value is -3 and for A point b value is 2. That's why the lower limit of y is -3 and the upper limit of y is 2. So if we put these limits, x lower limit is y -6, upper limit is minus y square, y lower limit is -3, upper limit is 2 in the integration, then your integration will be like this. Okay, so dx is inside the bracket and x limit is y -6 to minus y square. Outside it is dy and y limit is -3 to 2. Okay, now I want to solve the same question in the second through the second method, where we will integrate first with respect to y. Okay, so again you have to draw first region. So x is equal to minus y square, x is equal to y -6. Intersection point you need to find out. Then this will be your shaded area, which is your region of integration. In the method 1 we have drawn the horizontal strip, but here we want to find out, or we want to integrate first with respect to y, so we will draw one vertical strip. Okay, so vertical strip here, you can draw this vertical strip anywhere within the region. Okay, so if we draw this strip vertically within the region, or if we move this, okay, horizontally this from O point to the B point, from right to left, then what you will observe, that the entering of this strip is dependent on OB curve, but exit or leaving of this strip is dependent on two types of curve, OA and AB. Okay, so this region is now divided into two regions. Okay, so once again just observe it minutely. So it is like this here. If we move from A to B, then your leaving strip is dependent on AB, and if you move this strip from O to A, then the leaving strip is dependent on OA curve. So when the dependency of this strip is changing, then that is the break of region uh, we have to consider. So what we will do, this whole region, that is OABO. OABO is now divided into two regions, that is R1 and R2. So what we will do, it is OA and CO and ABCA. Okay, so how we will decide? These are only the two region. We have to break total region into these two break, region R1 and R2. So we have to check from where the dependency is changing. So you have observed that dependency is changing from the point A. Okay, from point A, then what you have to do, the from where the dependency is changing, you have to draw one line parallel to the strip, vertical strip hai, so you have to draw one vertical line. If it is your horizontal strip, then you have to draw one horizontal line. So here from A you have to draw one vertical strip, so what vertical line, so this is your AC line. So now this AC line will break the whole region into two regions. So first one will be OACO and second is ABCA. Okay. So now we have to find out the limits for both regions separately. And now we use one identity, that is I along the R f of xy dx dy, where R is the summation of two region, that is R1 and R2, then it is integral with respect to R1 plus with respect to R2 separately, and sum of both integral will be the given integral. Okay, so we want to find out the limits for this, for R1 also and for R2 also. So first I am taking same graph, but here I took two separate shaded colors for separate region. So this purple shaded region is our R1 and dark purple is your shaded region is your R2. Okay, so first we will find out the limits for R1 region, that is A, B, C, A. Okay, so in this region your vertical strip is already drawn, only you have to find out the limits for Y. So the lower limit of y is dependent on the negative side of the parabola BC. Okay, and parabola equation is x is equal to minus y square. So the y limit is minus under root of minus root x. Okay, so that is the negative part of the parabola. Now the upper limit where this strip leaving the region is dependent on AB line, and AB line equation is x is equal to y minus 6, so y value is x plus 6. So that is the upper limit, and lower limit is the negative part of the parabola. Okay, now you just move this strip horizontally within the light purple area. So it is start with B point and end up to AC line. So at B point x value is minus 9, and for AC line x value is minus 4. So the x limit will vary from minus 9 to minus 4. So I just put the limits later on. I have just found here the limits for x, y and x. Now we will consider the second region, that is R2, that is OACO. So now in the region OACO, we have to find out the limits. We already drawn one, that is a vertical strip. So we want to find out the y lower limit and upper limit. Lower limit will give, how we will get the lower limit? From where it is entering to the region, and the upper limit from where it is leaving the region. Okay, so first entering of this strip to the region is from the lower side of the parabola, which is the negative part of the parabola OC. So negative part of the parabola is y is equal to minus under root of minus x. So y is equal to minus under root of minus x is your lower limit. Okay, and where from where it is leaving the region, so it is the upper side, then upper side, that is the positive side of the parabola, that is OA. So OA from where that strip will be leaving. Okay, so positive side of the parabola will be given by y is equal to minus under plus under root of minus x. Okay, now we will again move this yellow strip horizontally within OACO region. OACO region, if we move this strip, so it will start from AC and go up to O point. So for AC, the x value is minus 4, and O point, the x value is 0. So the lower limit of x is minus 4 and upper limit of x is 0. Okay, so now our integral will be like this. So total integral is divided into two integrals, sum of two integral. In the first integral over the region R1, and the second integral is over the region R2. So the first integral limit is y is equal to minus root minus x to x plus 6, and the x limit is minus 9 to minus 4. And for the region R2, y limit is minus under root of minus x to under root of minus x, and x limit will be minus 4 to 0. Okay, so I hope it is clear. Now maybe one question may arise here, under root of minus x will be imaginary. No, not at all, because here x is moving from minus 9 to 0 in all, means your x is negative. When you put the x negative value, so then minus x will be positive, and it will give you only the real value. So you will not get any negative or imaginary or complex numbers here. You will get only real answer. Okay, so this last question will be very important when you will learn the third topic of multiple integral, that is change of order of integration. Okay, so I hope it is clear. If any doubt is there, so you can reach to me, you can ping to me. I will definitely will give you the clarity about your doubts. Okay, thank you.